let's work on the idea of conditional probability. What this means is we're looking at the probability of something occurring given that we know something else has already occurred. So for example, the probability of answer better off given they completed high school. So it's important to notice that one event is basically occurred first, completed high school, and after we already know that, we're thinking about the chance that they would answer better off. So using the rule in the textbook and using the way we have notation, I'm going to name some of these with letters to make it easier. Let's say that's A and high school is B. Well, maybe that's confusing because B is for better off. So I'm going to reverse these. Say that's B and that's A. So the notation for a conditional probability looks like this. It says, what's the probability of better off given completed high school? So this is the second event and this is the given. And what we know about how to find this is it comes from the chance of A and B, which we're going to find, and then we divide by whichever one was the given. So in this case, A was the given. So what this means to solve this is we have to figure out A and B, and we remember that's the same as the joint probability. That's the same as they both happen. So we're going to use this information and we're going to remember that it's out of 2,000. So the chance out of everyone that we would pick somebody that was better off and they finished high school is 140 out of 2,000. That's the numerator. That means chance of A and B. Now just chance of A, this is, I'll make a note here, this is the joint and this is the marginal. So the marginal chance of A just means out of everyone that completed high school. So let's go back here and remind ourselves this total is 400 that completed high school. So the marginal is 400 out of 2,000, which means the chance of saying better off given they completed high school is 140 out of the 400. Now, as a note here, if it's conditional probability, it's never out of all. So notice this resulted in out of 400, not out of 2,000, like what happened with the joint one was out of 2,000 and the marginal one was out of 2,000. But once we complete this, the conditional probability of answering better off given completed high school is not out of 2,000. So to make sure that this makes sense, I'm going to change the problem a little bit to show that it's not the same if we reverse it. So we're going to find the chance of A given B. This means the chance of high school given they're better off. So I'm going to reapply the formula. A and B are the two events, so the top doesn't change at all. But the given now is the B. So I need the B in the denominator. So since the top didn't change at all, it has to be the same number. But now what is the chance of B? The chance of B is the chance they're better off. chance of better off comes from this. And if we remember that we have to add those up, that's going to be 1,010. So that means 1,010 out of 2,000 was our chance of B. So 140 out of 1,010 is the number that are better off given high school, but 140 out of 400 is the chance of high school given they're better off. These are not the same things. So just to think about a completely different story without the numbers for a minute, the chance that it's raining given we're in Tacoma is different than the chance that we're in Tacoma given that it's raining. Maybe that it's raining all over the United States and the chance that we're in Tacoma given rain is very, very small, whereas the chance that if we're already in Tacoma, the chance that it's raining is probably larger. So whichever one's the given is really important that we adjust for the given first and then look at the chance of both things happening out of the given.